Hello everyone, this is your favorite neighborhood math professor and doing my last video about trigonometric equations, and I have a doozy. It involves squaring, it involves trig identities. It has a little bit of everything for everybody. So let's get started. For those in my class, this is chapter 7, skills test 7, problem number 41. Hip to be square. So before I start, I want to talk about trig identities. And the biggest trig identity, and probably the most important and famous trig identity, is sine squared theta plus cosine squared theta equaling 1. Notice, the square of the sine plus the square of the cosine gives you 1. Now, there's a lot of things that we can do to this one equation and get every other identity that we really want for this problem. For one, we can subtract sine from both sides and get cosine squared theta to equal 1 minus sine squared theta. All we have to do is subtract sine squared theta from both sides. Or we can subtract cosine squared instead of sine squared and get sine squared theta equals 1 minus cosine squared theta. Now, there are other two trig identities that are related to this one but can be derived. Now, as students in my class, I tell you that I am not a big fan of memorization. It is the lowest form of learning. So I would rather you memorize the sine squared plus cosine squared equals 1 and then use this identity in some operations to derive the rest. So we just derived two identities from this one original trig identity. Now, going back to the original trig identity, sine squared plus cosine squared equals 1, if we divide through this time, if we divide through by sine squared theta, that means we divide both sides by sine squared theta, we get a new trig identity. Namely, we get 1 plus, well, remember what cosine over sine is. Cosine over sine is not tangent. Tangent is sine over cosine. Cosine over sine is a reciprocal of tangent, which is cotangent. So cosine squared theta over sine squared theta is cotangent squared theta, and equals 1 over sine squared. So the reciprocal of sine is cosecant. So 1 over sine squared is cosecant squared theta. Now, obviously, we can do the same exercises here. We can subtract both sides by cotangent and get 1 equals cosecant squared minus cotangent squared. Or we can subtract both sides by 1 and get cotangent squared equals cosecant squared minus 1. Now, that is just one way we can use this original identity to derive a new identity. But another way we can do it is, instead of dividing through by sine, we can instead divide through by cosine. And when we divide through by cosine, and remember we have to divide both sides of the equation by cosine squared, and we get sine squared over cosine, which, remember, sine over cosine is tangent. So sine squared over cosine squared is tangent squared theta, plus cosine over cosine is 1. Any number over itself is 1, equals 1 over cosine squared theta, which 1 over cosine is the reciprocal of cosine, which is secant. So 1 over cosine squared is secant squared theta. And again, if we so desired, we can go ahead and then go from here and subtract both sides by 1 and get tangent squared equals secant squared minus 1, or subtract both sides by tangent and get 1, we get secant squared minus tangent squared equals 1. But for this problem, we really don't need all of the tangents and secants and cosecants. I just did this for your knowledge and how to be able to take this simple trig identity, which is a fairly commonly known identity, and derive from it all of the other trig identities that you need. So from this one trig identity, you can get the 8 other trig square identities that you need to work with. Again, do not memorize if you can, just memorize this one trig identity and derive the rest. It will save you a whole lot of headache and heartache, because then you won't say, okay, is it cotangent minus cosecant or is it cosecant minus cotangent? You won't have to worry about that, because you will be able to come up with it by deriving it from the original sine squared plus cosine squared equals 1. So I went ahead and written the problem that we're going to try to solve today, or attempt to solve at least. And this is again problem number 41 from Skills Test 7 of Chapter 7. And notice this is unique compared to all the other problems that we faced, because we have both sine and cosine in the mix. The previous problems on the worksheet, that you have noticed that there was either all cosine or all sine. And now we have sine and cosine added or subtracted in the same problem. Now, it would be nice to get an equation that is strictly one trigonometric function, either all sine or all cosine, and that's what I'm going to attempt to do. So the first thing we should do is clean this up a little bit by adding sine to both sides. So we have a negative sine theta on the left hand side, and we're going to add sine theta to both sides. And by doing so, the problem is now going to read cosine theta minus 1 equals negative 2 sine theta plus sine theta. Remember, we are going to treat our trigonometric equations or trigonometric functions as a variable into itself. So this is no different than saying x minus 1 minus y equals negative 2y. And I'm just adding y to both sides, so negative 2y plus y would be negative y, and in this case, negative 2 sine theta plus sine theta would be negative sine theta. Now, we're in a little bit of a quandary, because now we have cosine theta minus 1 equals negative sine theta. Can't really do much beyond this. However, we can try to change the sine to a cosine or a cosine to sine. And, well, we know that from the identity above that sine squared theta is equal to 1 minus cosine squared theta. But we don't have sine squared theta. We instead have just sine theta. So we have to change sine theta to sine squared theta. Now, this goes back to an identity in mathematics that, if you are familiar with, I'm going to just reiterate that if you have two identities equal to one another, or two quantities equal to one another, A equals B, you can square both sides and preserve the equality. That means you can square both sides. So, for example, if x equals 4, then x squared equals 16. So, what I'm going to do is I'm going to implement this formula by squaring both sides. Now, when I square both sides, I'm not just going to square only the cosine on the left-hand side, but the entire function. And on the right-hand side, I'm going to square the negative sine theta. So, when I square the cosine, this is no different than if I was dealing with x minus 1 squared. Now, remember how to square a binomial. It is the square of the first times 2 times the first number times the second number, which is negative 2x, and plus the square of the second, which is 1 squared, which is 1. So if we square the cosine minus 1, we'd get the same result, or a similar result. We would get cosine squared theta times 2 times 1 times cosine, or negative 1 times cosine, which is negative 2 cosine theta, and minus 1 squared, which is 1. So it'll be plus 1. And negative sine theta, when we square it, we have a nice outcome, because when we square a negative, we remove the negative, or the negative goes away, and we get just sine squared theta. Now, we have sine squared theta, and from my identity above, right here, we know that sine squared theta equals 1 minus cosine squared theta. And so we're going to go ahead and make that substitution. So now our problem is going to read cosine squared theta minus 2 cosine theta plus 1 equals 1 minus cosine squared theta. So now we're going to add cosine squared theta to both sides. Now the reason I want to do this is because I'm dealing with a quadratic, okay? This is a quadratic trigonometric equation. Try to say that 5 times fast. But just like any quadratic, whether it's polynomial or transcendental in origin, to solve a quadratic, we have to set one side equal to 0. So we're going to add cosine squared theta to both sides. And our resulting equation is going to be cosine 2 cosine squared theta minus 2 cosine theta plus 1 equals 1. Well, we still don't have one side equal to 0, so if we subtract 1 from both sides, we get 2 cosine squared theta minus 2 cosine theta equals 0. Hooray! We got one side equal to 0. Now, how do we solve this? Well, what if we had, instead of 2 cosine squared theta minus 2 cosine theta equals 0, if the problem was 2x squared minus 2x, what would you do? If it was 2x squared minus 2x equals 0, you'd factor out a 2x. So that's what I'm going to do. Instead of factoring out a 2x, I'm going to factor out a 2 cosine theta. When I factor out a 2 cosine theta, I get left with cosine theta minus 1 equals 0. Now, remember, the cool thing about 0, and why 0 is one of my favorite numbers in mathematics, is because of the zero rule property. That says if you have two numbers, x or y, that are multiplied together to give you 0, it means that either x equals 0 or y equals 0. No other number in the infinite number sequence has that property. If you have two or more numbers multiplied together and that gives you 0, that means at least one of those numbers has to be 0. So we're going to implement this property into our trig equation. So if we have 2 cosine theta times cosine theta minus 1 equals 0, that means either 2 cosine theta equals 0 or cosine theta minus 1 equals 0. Well, if we divide both sides by 2, we get cosine theta equals 0. And in this side, we said we'll get cosine theta equals 1. Now, what angle measures give you a cosine of 0? Well, between 0 and 2 pi, the theta, or the angle measures that give you a cosine of 0, are on your y-axis. So the angle measures are pi over 2 and 3 pi over 2. Now, what about 1? When is cosine theta equals to 1? Well, remember, cosine theta oscillates between -1 and 1, and it reaches 1 at its maximum point, and it reaches 1 at, cosine is 1 at 0, and that's it. So it looks like that our solution would be 0, pi over 2, and 3 pi over 2. However, we have to check to make sure that these answers are are true to the original equation. Remember, the original equation stated that cosine theta minus 1 minus sine theta equals negative 2 cosine theta. So we added sine theta to both sides and got cosine theta minus 1 equals negative sine theta. So that is really our original equation. We want the angle measures such that cosine theta minus 1 equals negative sine theta. And now we're going to check our answers to see if they all yield a true result. So we're going to plug in 0 for cosine, and we're going to go cosine of 0 minus 1 should equal negative sine of 0. Well, cosine at 0, remember we're dealing at the angle measure, is not 0. The cosine at 0 is going to equal 1. And so 1 minus 1 should equal negative sine of 0. Well, sine at 0 degrees or 0 radians is 0. So 1 minus 1 equals 0, so that works out. So this solution is okay. Now we're going to go back and we're going to check, instead of 0, we're going to plug in pi over 2. We're going to plug in pi over 2. Now this is necessary because not all solutions may work. Now it could be the case that all three values may check out, but this is not always the case, and we need to just, for our betterment, know that all three solutions are valid. So cosine pi over 2 minus 1 equals negative sine pi over 2. Well, cosine pi over 2 is equal to 0. Remember, you're on the y-axis if you're at pi over 2 degrees, radians. So cosine is 0 on the y-axis, minus 1 equals negative sine of pi of 2. So sine of pi over 2 is 1. So 0 minus 1 equals negative 1. So that also checks out. Now, so far so good. So it looks like that all of this was for naught because we've not found anything that sort of went against our answers that we found. So let's check, just for completeness sake, 3 pi over 2. Now, cosine at 3 pi over 2, or at 270 degrees, again, you're on the y-axis, so the cosine will be 0, minus 1 equals negative sine of 3 pi over 2. Now, the sine of at 3 pi over 2 is negative 1. So 0 minus 1 is negative 1. However, the negative of negative 1, two negatives make a positive, is equal to 1. So this solution does not work. And it's a good thing we went to check at our answers, otherwise we would have gotten an erroneous solution. So, it's a good thing we went back to check, because just like my kids, they sometimes give me bad answers. So, after checking and verifying the correct answers, we found that our solution is only 2 of the 3 answers that we found, which are 0 and pi over 2. And if you look at your answer choices, this is answer choice D on the worksheet. Well, I hope you learned a lot from this whole sequence of trig equations and how to solve both linear and quadratic type trig equations, and how to replace one trig identity or one trig function with another. And if you have any questions, you can contact me through Remind or email me, or you can text me if you have my phone number. And I will talk to you next time. Thank you.